Thank you for joining us for today's webinar, Design, Analyze, Operate with SmartPlant Electrical and ETAP. I'm Justin Lucas, your host for today's webinar, and leading today's webinar we have Frank Yetap. He's the Executive Director of Global Business Development for our Engineering and Schematic Solutions here at Intergraph. So without further ado, I'll turn things over to Frank, and he can introduce the rest of the team and get off with the introduction to the webinar. Frank.
All right, thanks Justin. Also welcome from my side. Good morning or evening, depending on what time zone you're in. And yes, we're going to talk about exciting work process together with our partner. We're very happy in today's webinar that we are joined by our long-standing and good partner Yetap, based in California here, and is focusing on the analyzing of electrical systems here. So what I'm going to do is I'll talk a little bit about the university objectives. You know, these webinars as well as the workshops we have started last year in the different regions are under the umbrella of the SmartPlant University, with the objective, of course, to inform you about the latest and greatest and get you the hints and tips and workflows to make sure you take maximum advantage of the solution we're providing. Talk a little bit about this solution that we offer in engineering and schematic. Then Frank Kling from the ETAP product will actually introduce the company a little bit, tell you a little bit about ETAP, and then we'll get started with the meat of the webinar, being the workflow and the presentation demonstrations. And like Justin was just mentioning, that at the end, hopefully we'll have some time left to do some questions and answers, but don't worry, if you have your questions, enter them at any time. We'll, even if we cannot have any time to answer them, we'll answer them through some communication with you after the webinar. So SmartPlant Enterprise is a big slide here with all the different products that we have, from engineering, schematic, 3D modeling, analysis, procurement, and of course the partners, in which ETAP actually sits in that particular box. But the box on the left hand, which is a little reddish color they made, are the products that are under my responsibility, being engineering and schematic products. And one of them is SmartPlant Electrical. But I always show this slide because even though you can use SmartPlant Electrical perfectly well standalone and offers a lot of value to you, I mean, the 1-on-1 is 3 applies here, that you can plug it into the environment, to the enterprise, and interface with others and downstream solutions, like for instance interface with SmartPlant Instrumentation or SmartPlant 3D for cable management. Now the SmartPlant Engineering Schematic solution itself has 3 main products: the P&ID, Instrumentation, and the product of today's webinar, SmartPlant Electrical. Now we got some applications, some tools, some solutions that complement them, like for instance SmartPlant P&ID Engineering Integrity, which is a rule system that checks the design while you do the design. Is a very cool and value-added solution. Or Operation Excellence in the Instrumentation, that does calibration and other tasks for operations. And then of course you see ETAP-SPEL, which actually the 2 and 2 makes certainly 3, because that complements the whole work process that we're going to actually show today and show you the value and how cool that is. And I'm pretty excited about that already for years. But in addition to the regular workflow we always show, basically the bidirectional interface doing an analysis, ETAP takes it one step further, and today shows you the real time, which actually brings the whole electrical system in the operational phase, which I think is extremely important. Because think about it, pipes are important, heat exchangers are important, but if there is no power, there is no pumping, and there is no product. So the electrical system, is also extremely important in the operational phase. And if you have tools to monitor that, constantly and make sure it's all operating as you designed, then that'd be cool. Okay, well, I was asked, to introduce actually ETAP myself now, so I'll do that. I hope I do it justice. I mean, it's a great company. It's been around for a long time, and you know, I met the founder a few times, and he's a passionate man, and he has long you know, experience in this particular field, and his company has built a market-leading solution that has, as you can see, an enormous amount of licenses out there, mostly used by any major company out there. There's about 10,000 customers, you know, and they do, you know, basically three main things. That is the design and analysis of the solution. That is what I talked about earlier, when we can hook up SmartPlant Electrical and make sure the design is right in a bidirectional way. But also they do this real-time power management, and that is cool for the owner-operator phase, where you actually can monitor, just like DCS for instrumentation. This is actually a DCS, you know, for the electrical system, how the system is behaving, and also do some load shedding, like, you know, if some loads are, you know, failing, that you make sure that the critical loads are actually stay up and running to make sure your product is still being produced. And then lastly, they also support the smart microgrid solutions. Very exciting, and actually, you know, Yetap themselves took it on to have their own microgrid in their office. I've seen it myself. You know, you got the solar panels they have there, and they generate some electricity for their own use, and manage that with their own tools. So I guess that's the best proof. You know, you use it yourself as well. So that's very cool. So, like I said, the university is to increase, of course, your knowledge about the products, our products. But in this case, you know, I'm always very happy if we have partners joining. So, how we can show that we can get together and do a 1 + 1 = 3 for you and offer more value, you know, with the combined solution, and this is a prime example of that strategy. And like I said, I'm very excited about that. We want you to understand what is possible, and you may not know that, or you may forgot that. You know, there are so many capabilities that we offer in these products that I can understand, and I have it myself also, that sometimes you don't remember that anymore, or you don't know that actually this particular workflow is possible as well. So that's what we focus on. We want you to push the envelope and take the maximum advantage of the investment you made in both Yetap and SmartPlant Electrical products, and think that is good for all of us. That's good for you. That's also good for us, because we want you to do that. And of course, you have the opportunity to ask the key players in our team questions during these webinars, and I encourage you to do so. Now, you know, I'm engineer from background myself, not a software guy, but an engineering guy, and so I know that if you do a project, you have a certain scope. You have to create one-line diagrams or a certain, you know, power system for a plant or a facility, and that's what you need to do. So the features and functions and the technology is, to me, is the enabler to get the work done. So I'm very hot and very keen on these workflow diagrams that we started several years ago now, that shows basically the steps that you have to take to accomplish that particular scope of work, and of course with the associated benefits. Because there is no benefit, you know, I cannot expect you to use the product, you know. So we want you to get value, you know, either in quality, productivity, and so on and so on. So these workflow processes, these swim lane as we call it, are very important. We try to use them all the time in our presentation to show you that we really dare to solve a particular problem for you in your work process, and offer you the deliverables with the benefits, as I said, for your project or for your plan. So that's very important. Now, today's workflow, like I said, it is three parts. It is about design. You know, first we'll talk about the SmartPlant Electrical. Yuval Adler will present that particular part, you know, showing SmartPlant Electrical key features and how it actually can be used to design the electrical system using our product, and also create the associated deliverables, of course. Now, next, once we have designed it, you know, Ali Hamini will, from Yetap, will actually then demonstrate, you know, taking the design from SmartPlant Electrical and then analyze it. You know, because we in SmartPlant Electrical, we don't support, or we don't offer this comprehensive analysis capability that Yetap has. So, you know, the short circuit, the relay coordination, and so on and so on. So we want to validate early in the design process if the design is solid, safe, and reliable. So that's the part that that ETAP plays. And then, of course, if they found things that need to be changed, they'll feed it back and we'll update the design. Now, lastly, and I said that's very exciting, I think, to me, and also ETAP, and that we can then take the electrical design, of course, in the operational phase, and then monitor and optimize and predict how the system is going to behave in operation, and then they have very sophisticated tools to make sure that if something goes wrong, that we know it early enough to take corrective action. So Yuval and Ali will demonstrate that in a minute. So like I said, the workflow is important. Of course, there are many different workflows that different companies have. So don't get suddenly hang up on saying, okay, this is the only workflow you're supporting. No, this is just an example of what we think would be a good workflow. But there are many different workflows, and we will give a short overview of the product, how this fits and how this supports this particular swim line diagram. So you can see a little bit more focused in this particular work process. And like I said, once we have created the design to a certain point that makes sense, of course, we will actually then export the information to ETAP. They import it and then validate the design. Of course, the scope is to create the total electrical distribution system for the plant or for your facility, and make sure that it is designed optimum, cost-wise, but also technically reliable-wise as well. And then, of course, at the end, we're going to hand over the whole thing to operations after the commissioning as an as-built. Both and SmartPlant Electrical have the as-built situation, and ETAP as well. And then, like I said, to the real time, they can then monitor the system as well. All right, so today we're going to show SmartPlant Electrical, the design. We're going to publish or give the information to ETAP. And ETAP then validates and analyzes it, and we can feed it back. Like I said, if they find a breaker or a cable that's not rightly sized, we can make sure that those two environments are in sync. And then later, when it is in operation, then the real time will actually take over and monitor that. And if they find things during operation that need to be changed on the design side, again, the same thing. Then basically ETAP can say, wait a minute, this needs to be changed on the design, different cable, or whatever. Then they can actually feed it back to SmartPlant Electrical and update the as-built or make any changes, and voila, we can have the circle around. So it's very exciting, very powerful. This is a unique solution, I believe, in the market that can, get you from the design all the way to operations as well. All right, so enough talk for me, and without further ado, I'm going to hand it over to Yuval, who's going to start it off in SmartPlant Electrical and start the design process. So Yuval.
Yuval, make sure you unmute yourself.
Hi everybody, hello everybody. Thank you for participating in the webinar. My name is Yuval Adler from Intergraph, and I will take part in the demonstration today. The first part includes SmartPlant Electrical in design phase, following with demonstration of the SPEL ETAP interface, and export SPEL cable library and project data to ETAP. The second part will be presented later by Ali Halimi from ETAP to import the SPEL data following with load flow real time and more. After ETAP will finish the validations, they will export the change in the data and cable library to SPEL. The last part will be in SPEL to import the data back and finish the round trip. So we will start with the design phase. Before we will start a demo that exchange data between SPEL and ETAP back and forth, we will demo SPEL workflow that can be used in design phase. During the design phase, we built in spare switchgear connected to transformer that feeds motor control center MCC80. At this point, if we need to produce single line diagram for MCC80, we can select from electrical index MCC80, right-click, and from the shortcut menu, select Generate SLD. From the single line diagram option, enter MCC80 for document number and click Generate. Review the SLD drawing. We include 4 feeders. Each feeder branch includes feeder circuits with disconnect electrical equipment, power cable, load, and control station. We need to continue the design and add another feeder branch from new 100 kilowatt heater. To do that, we will use typical cable block diagram. We will first save, revise, and close the single line diagram, and then start to create the new branch using typical cable block diagram. Click the Save button to save the single line diagram. From the document Single Line Diagram folder, select the new SLD document MCC80. Right-click, and from the shortcut menu, select Document Properties. Enter the revision information and click OK. When done, close the document. Typical cable block diagrams that create the Reference Data Explorer window are graphical templates that one can use as design sheets to create project data and deliverables. Let's review the typical cable block diagram 100 kilowatt 3-phase heater that we will use later as a design sheet and create from it the feeder branch in MCC80 for new 100 kilowatt heater. Select from Reference Data Explorer the typical cable block diagram 100 kilowatt 3-phase heater. Right-click, and from the shortcut menu, select Open. Zoom in and review the drawing. This drawing includes typical feeder circuits, typical power cable, typical heater, typical control cable, and typical control station. Each typical item in the drawing links to reference item. For example, select the typical heater in the drawing, right-click, and from the shortcut menu, select Find in Reference Data Explorer to navigate to the reference heater item in the Reference Data Explorer window. At this point, we will close the typical cable block diagram and learn how we can apply and use it as a design sheet to create for it the feeder branch in MCC80 for new 100 kilowatt heater. From Electrical Index windows, Documents, Cable Block Diagrams folder, right-click, and from the shortcut menu select Create from Typical. In the Find dialog box, find the typical cable block diagram 100 kilowatt 3-phase heater and click OK. In the Create New Plant Circuit dialog box, enter MCC80, bus 80, select the option to create new cell, and create OK to start the item creation. The result of the operation are new feeder branch in MCC80 for the 100 kilowatt 3-phase heater that can be seen in Electrical Engineer and in the Electrical Index windows. And new deliverable cable block diagram CVD drawing 11 based on the typical cable block diagram 100 kilowatt 3-phase heater. After adding the new feeder branch to MCC80, we can reopen the SLD for MCC80 and review the change, including using the compare feature that can compare the current drawing data with last archive revision data presented to the user in comparison report spreadsheet and cloud symbol in the SLD drawing for each change property. To open the SLD and use the new branch feeder, right-click on the SLD document MCC80 Start menu, select Open. You can see in the Open drawing the new feeder branch that includes the feeder circuit with the circuit breaker, the power cable, the heater, and the control station. We will close the SLD document and run the compare feature. Close the SLD drawing. Right-click on the SLD document MCC80, and from the shortcut menu, select Compare Document. The Compare Document dialog box, select Revision P0 to compare the current data with the archive revision P0, and select Compare to start the compare process. You can see the compare result in the comparison report spreadsheet and in the compare SLD that includes the cloud symbols. At this point, we would like to check the calculated bus load at MCC80 by using the batch load association feature to review the total load on the bus and verify that we did not exceed the limits set by the engineer. From Action menu, select Batch Load Association, select MCC80 and Bus 80. Verify the calculated result. Notice that if we get into overload situation, SPEL allows to move complete branch from bus to bus in single and batch operation and perform load balancing. At this point, we would like to generate motor schematic for motor M20, which is one of the loads fed from MCC80. The typical schematic template associated with this motor is motor 480 complete typical. To generate new schematic, select motor M20 and select generate schematic. View the motor M20 schematic results. Zoom in and notice the macro or smart text such as the macro for item type or for the motor rated power that will bring from the database the most updated value. Select Save, which saves the schematic as a document in the schematic drawing folder with the name matched to the motor item type. Close the schematic document. SmartPlant Electrical provides you with a number of predefined reports. You can run the reports or use them as a report template for other reports you'd like to create based on Microsoft Excel. You open a report from the report menu or from the register report folder. Every time you generate a report, the software retrieves the relevant data from the database and calculates the pertinent results based on the currently retrieved values. For example, let's open and review the whole feeder load summary enhanced report. This report is a summary of the loads that are connected to the buses of the power distribution board. This report is based on either the consumed or rated power of the selected loads. Another report review is the cable schedule. Notice it also includes for each cable the cable brand that is associated with each cable in the routing tab. The last report we'll review at this point is electrical load list that you generate based on the load item type. The software retrieves the load tags with the relevant load time data, such as rated power, brake power for the motors, as well as value for efficiency, power factor, full load current, so forth. SmartPlant Electrical publishes single line diagram to ETAP using electrical analysis SLDs. To generate an electrical analysis SLD, select the network in Electrical Engineer and from single line diagram options UI, enter document number, select electrical analysis SLD type, and start the generation. Following the generation, you can view the results, reposition item, and make adjustments. Notice the transformer T3 currently rated 300 kVA, and later in the demo, we will see how we can adjust it based on ETAP load flow study results. After viewing the SLD results, you can save it to the database as a new electrical analysis SLD document. After create new electrical analysis SLD document, you can publish the document by right-clicking the new SLD document, and then on the shortcut menu, click Publish to External Analyzing Tool. On the Publish to External Analyzing Tool dialog box, save the drawing as an XML file, which will be used by ETAP as an import source. You can synchronize the SmartPlant electrical reference cable with the ETAP cable library of the particular ETAP project if you want to have the commonly shared cable library. This synchronization is optional. If you don't synchronize the libraries, both applications function independently of the cable library of the other application. However, if you synchronize the cable library, each application will identify the reference cables that were specified by the other application. The SLD we publish include cable 1 that associates to reference cable 3C40G-SPEL. We'll go through the procedure to export SPEL cable library to synchronize ETAP cable library with reference cable 3C40AWG-SPEL. The steps to export SPEL cable library are on the Option Manager menu bar, click Interface, ETAP, Export Reference Cables. On the Reference Power Cable Selection method page, click the power cable with selected cable specification option. Under Cable Specification, select the appropriate specification and click Add. After clicking Next, the software will display a list of reference power cables that have cable specification you select on this page. Click Next, select the reference cable that you need, click Finish, review the export results page and click Close. The exported cable library data is saved into MDB file defined in Option Manager location page. Thank you, and we will continue now the demonstration in ETAP. We will move the presenter right to Ali to do the next part of the presentation. Also,
all right, thanks, Yuval. Very good. I think we move on to quickly a poll question while we change presenters. So, Justin, can you do that?
Sure, Frank. Our poll question for today's webinar is the following. What are the most challenging tasks during the electrical design project cycle? The answers are load distribution and assignments, system validation and analysis, creating the deliverables, or I don't know. Just click on the answer that best applies to you to vote, and I'll leave the poll open for about 25 seconds or so to give everyone a chance to answer. Once again, I'd like to remind everyone that if you do have any questions during today's webinar, just type them in at any time, and we'll get to as many as we can during the Q&A portion of the webinar. All right, looks like we almost have everyone in. So if you haven't voted, please do so now. Oops. Okay, here are the results of the poll. Looks like 43% said system validation and analysis, 24% said creating the deliverables, 19% said they did not know, and 14% said load distribution and assignments.
Okay, it's good. Yeah, it's important, and I like that the poll questions gives us a two-way street to see, if we are focusing on the right solutions to meet your needs there, and certainly the analysis part is next with Ali. So you will see how that works then. So Ali, I think the floor is yours.
Thank you, Frank. Hello, everyone, and welcome to SPEL ETAP Design, Analyze, Operate webinar. My name is Ali Halimi, and I'm the product manager of ETAP-SPEL interface on the ETAP side. In today's webinar, we're going to demonstrate two sections basically in ETAP. The first one is the analysis and validation of the retrieved data published from SmartPlant Electrical into ETAP, and perform basically load flow study in ETAP to make sure the equipments are sized properly. And then we will demonstrate the operation, monitoring, and prediction piece by taking the ETAP project to real-time online mode and monitor the system behavior and different basically conditions such as losing a generator and such, and monitor basically shedding some loads and see how a system reacts. At the end, we're going to send any possible updates to SmartPlant Electrical and just retrieve the data from that side. With that, please let's go ahead and start the demonstration on ETAP side. I'm going to start it right now.
My name is Justin Delos Reyes, and I'm one of the sales engineers here at ETAP. Today, I will be going over the ETAP SmartPlant Electrical Interface, which is a tool used for exchanging data between ETAP and SPEL. The ETAP Data Exchange Interface is able to perform data synchronization with SmartPlant Electrical published project data. ETAP may use information available in both SPEL and ETAP to add, remove, and modify elements, and then perform an auto-creation of the one-line diagram. Multiple data transfers between ETAP and SPEL is also possible. This means a project may be initiated in either SPEL or ETAP, and data can be exchanged between the two tools as many times as necessary. SPEL is able to publish project files that include SmartPlant Electrical project data and cable library files. These files may be read and imported to ETAP. We may synchronize the project data between SPEL and ETAP. Here is the flow of how data is exchanged between ETAP and SPEL. We will demonstrate here the synchronization from ETAP and bring in the one-line diagram from SPEL. SPEL's external analyzing tool allows publishing of a single-line diagrams. When SPEL exports a single-line diagram data, the data is stored within an XML file. ETAP can import the single-line diagram data, and this can be done by selecting the Import SPEL Project Data option from the SmartPlant Electrical menu. Select the SPEL Published Single-Line Diagram XML file. The display windows of Import SPEL. We are able to change the mapping of SPEL and the ETAP elements here. After importing SPEL data, ETAP will display the Accept/Reject Actions window. At this time, the user will need to select which elements to add, modify, or delete from the Accept or Reject Actions list. The user may then select the Continue option to complete the import. The SPEL project single-line diagram is imported into the ETAP one-line view. ETAP creates a diagram with SPEL data and the connected elements. We may also synchronize the cable data between SPEL and ETAP. SPEL's Option Manager provides an option to export reference cable data from SPEL. When SPEL exports the reference cable data, the data is stored in MDD format. We will demonstrate here the synchronization from ETAP and bring in cable library data from SPEL. ETAP can import the reference cable data file from SPEL to the ETAP library by selecting the Import SPEL Cable Lib option. Simply point to the reference cable MDB database file exported from SPEL. Select OK to complete the import. Once the import has finished, the SPEL reference cable data will have been brought into the ETAP library. Here we can see the imported SPEL cables. Later on in this presentation, we will be demonstrating ETAP real-time. The addition of metering devices such as multimeters, potential transformers, and current transformers are necessary in order to run ETAP real-time applications. In this example, we will be adding metering devices to the ETAP project that were previously imported from the SPEL project file. Let's add a multimeter to the ETAP one-line view and connect it to the existing current transformer. Multimeters may need to be connected to both the current transformers and the potential transformers. Make sure any necessary current transformers and potential transformers are added to the ETAP one-line view and connect them to the multimeters. Here is the project after adding multimeters and potential transformers and connecting them to the imported current transformers. The multimeters will also require a tag file to be created for real-time applications. For more information, you may refer to the ETAP real-time video tutorials. Once the ETAP project has been set up with metering devices, we can then proceed to verify that the ETAP project data has been imported properly, and then we may perform ETAP real-time applications. We will show here that the imported SPEL project is able to run ETAP studies, such as a load flow analysis. By switching to load flow analysis, we can verify that the data from the published SPEL project file has been properly imported to the ETAP project. Now that the SPEL project is imported properly to ETAP, let's run load flow analysis. After running the load flow study successfully, we can see any pending issues to be corrected in the project alert view. The alert view provides a red bell for critical warnings, or a yellow triangle if the study is fine. We may use ETAP to correct any sizing issues prior to sending the project back to SPEL. As seen in the alert view, 2-winding transformer T3 is overloaded. The overload condition can be fixed by increasing the power rating of the transformer. Save the changes and rerun load flow. We will notice that the transformer is no longer alerted as overloaded. As we can see in the alert view, the fuse 1, is overloaded. The overload condition can be fixed by changing the settings of the fuse. Change the setting of the fuse by selecting another fuse from the ETAP library with a larger size. We will notice that the fuse is no longer alerted as overloaded. We may also change the settings of the circuit breakers with overload conditions. As seen in the alert view, the low voltage circuit breaker CV3 is overloaded. The overload condition can be fixed by changing the settings of the low voltage circuit breaker. Change the setting of the low voltage circuit breaker by selecting another low voltage circuit breaker from the ETAP library with a larger size. If we run load flow again, the low voltage circuit breaker that we have corrected will no longer have an overload condition. Select Cable Load Amp located in the Load Flow Study case under the Info Page tab. Cable 1, go to the Info tab and select the library. After doing so, then run load flow analysis. The alert view displays Cable 1 to be operating with an overload condition. The overload condition can be fixed by changing the cable size of the cable. Notice that the operating current is higher than the allowable opacity of the cable. We can resize the cable by using the ETAP cable sizing feature. The sizing phase page of the cable editor will include optimal sizes for the cable. We can go ahead and select an optimal size cable as shown here. Save the changes made and rerun load flow again. This will let us know if the cables have been resized properly. As you can see, the cable is now properly sized and load flow alert view no longer indicates an overload condition. Next, we are going to have one of our sales engineers here by the name of Frank Kling explain the next portion of the SPEL to ETAP presentation.
So far, we have demonstrated the importation process of SmartPlant electrical data into an ETAP project and synchronized the cable libraries. Assuming that the system is adequately being analyzed in the simulation world and the design has been approved based on the analysis results and corrections in so many iterations between ETAP and SmartPlant electrical programs, the network can be prepared for an online real-time operation where the simulated ETAP model can be taken into the online mode and connected to real system data. But before we go there, we're going to give you a brief introduction on what the ETAP real-time solution is all about. ETAP Real-Time is a complete lifecycle management solution designed and developed for engineers, managers, dispatchers, and operators of electrical power system. ETAP can be utilized through the whole lifecycle of an electrical power system network, from the design stage through the engineering, commissioning, and then turned over to operations and maintenance, and then followed up back into the planning sections with the reliability and the planning department to enhance the design as functionality or requirements change in the electrical system. An integrated power system solution has its own life cycle. There is the design, construction, commissioning, and operation and maintenance phases of this life cycle. The ETAP tools can be utilized in an intelligent modeling environment coupled with integrated analysis tools and enforced by rule-based driven designs. From there, implementing this same tool with the construction packages, engineering teams can develop schematics, drawings, equipments, cabling, and other different types of deployment packages that are turned over for construction drawings. Also, revisions and version control can also be easily managed and keep the integrity of the design. This information can then also be passed as the commissioning reference to the commissioning teams. From there, they can take this, directly commission the system, and making sure the integrity of the design is carried out through the commissioning periods. Once the system is commissioned, it is now turned over to operations, and the real-time system really shows its value. From there, the model-based solution can now be brought online with real metered information populating the electrical model. This now provides the operations staff a much cleaner and a much more comprehensive view into the electrical system. From there, they are able to automate and simulate different opportunities inside the electrical system without actually physically stressing the equipment. There's also the ability now with this type of deployment to have complete asset management of the electrical network. The power management workflows can then be written, and you can actually validate switching, sequencing, and other operational parameters. It also provides you a set of rule-based plans that you can do for emergency recovery due to an unplanned schedule outage. ETAP Real-Time is a proven technology first deployed in a refinery in 1992. As automation technologies have progressed, the ability to deploy an ETAP real-time solution has greatly reduced in the actual infrastructure cost that is to take advantage of. Back in 2008, it was selected as Product of the Year by Consulting Engineer magazine. As you can see, we have made steadily increases in delivering more and more functionality. In 2011, ETAP Real-Time released its microgrid controller for the renewable industries. And even as we move forward into today, we are now released on a 64-bit platform to take advantage of ETAP Real-Time in both our distribution and transmission environments. The ETAP real-time solution is a suite of applications. As you can see from the screen, we will be focusing on power system monitoring and simulation, of which other components such as advanced monitoring, energy accounting, predictive simulation, event playback, and load forecasting are all subsets of this solution. We will also spend a little bit of time focusing on intelligent load shedding. The ILS portion of the product allows us to do intelligent load shedding and validate the load shedding solutions prior to bringing the system online. ETAP Real-Time is the only true model-based solution available today in the industry. We start with the same electrical model that is being done in the design phase and bring that to the operational floor. This allows the operational team to have the same type of asset information that was used to design the system available for them when they're troubleshooting electrical problems or trying to prevent electrical problems. With just a click of a button, you can bring up the operational information into the same view as you did from the design floor. But instead of typing initial conditions in with keyboard, you are now allowed to bring in data collection information coming from your existing SCADA or DCS. To take advantage of a model-based power management system, you are required to have an accurate, updated electrical model. You also need an interface to real-time data and the proven analysis engines. Then you have the ability to run multiple scenarios against the data that's coming in to validate the accuracy of your model. The biggest benefit of an ETAP real-time systems to an end user is it proves that the electrical model that people are going to rely on to either troubleshoot or expand is up to date, the correct information. It also provides a very clear representation of the system. And this becomes very important when you're trying to troubleshoot problems or validate operational procedures, planning for future expansion. So real-time electrical intelligence is invaluable when you have a multi-million-dollar facility that is down due to an electrical problem and you don't even know if the reference you're looking at is correct. ETAP Real-Time will always keep this electrical reference available to the operations and management staff of the asset owner. Clients who could benefit from predictive simulation, electrical SCADA, optimum load shedding, and energy management are all candidates for ETAP Real-Time. As you can see, multiple vertical industries who require electrical power as the mainstay of their operations should take advantage of this tool. Having one tool that can be used for design and also a system simulator for operations is a key asset of ETAP Real-Time. Validation testing and switching sequence management, again, is another valuable operational tool that ETAP Real-Time provides for its users. Many electrical facilities today have some type of electrical SCADA for monitoring and control, but many of those are not based on true electrical model. ETAP Real-Time being model-based will allow you to take alarms coming in from devices in the field and marry them up with intelligent electrical attributes in the ETAP model for a much more intelligent alarm system. If you have on-site generation, you can also take advantage of the optimum load shedding application ETAP Real-Time provides. And if asset generation is a very key component of your electrical system, our energy management suite will allow you to provide automatic generation control, load frequency control, and economic dispatch. Let's take a closer look at one of the ETAP Real-Time applications, Power System Monitoring and Simulation. ETAP PSMS is a multi-console client-server monitoring system. It provides a graphical representation of the ETAP one-line diagram. It allows you to historically archive data and retrieve it for display. You can display both electrical and non-electrical metering tags on the system, very similar to today's HMIs. It supports native OPC and native protocol interface layers to connect to intelligent devices already in the field, provides multi-access levels for operator support. It also allows you to provide asset information and power system performance calculations for stable operations. It can safeguard against unauthorized operations by allowing the operators to test scenarios before they actually implement them in the field. It can quickly eliminate what's not the problem when you have an electrical shutdown and get to the grassroots cause of the interruption. And again, the most beneficial aspect of this type of technology, it allows you to predict and prevent events before they occur. ETAP-ILS, or Intelligent Load Shedding, is another advanced application that is part of the ETAP real-time suite. Intelligent load shedding, load preservation, load restoration, and load shedding validation are all part of this application. ETAP-ILS provides very fast optimum load shedding for electrical disturbances and loss of generation. The reason it provides very fast load shedding is because it is predictive. Load shedding calculates the minimum required megawatt to be shed for each subsystem according to its type and location of the disturbance, or the actual operating generation, spinning reserve, the loading configuration, and load distribution and priority. Again, being a model-based solution, ETAP-ILS has all this information, and it can then be used to optimally configure the triggers and the commands to trip the loads in an optimum fashion. ETAP-ILS is an integral part of ETAP. This patented technology works directly with the ETAP one-line diagram, analysis modules, and real-time modules. The ILS works on a concept of predictive system response to different disturbances under the actual operating conditions. The ILS provides fast optimal load shedding for both transient and steady-state conditions. ETAP-ILS provides the operators the capability to change the load shedding priority, the logic, and the schedules directly from the one-line diagram with a user-friendly interface. For these changes, ILS will automatically update the ILS controller programs. This is part of the demonstration we'll show you here in just a second on how the operator has this information at its fingertips. Once the system is configured, the operators can actually just let the system run and make the intelligent decisions that have been pre-validated before the system went online. The most important benefit of ETAP-ILS is the load shedding validation. With the simulator, ETAP-ILS recommendations can be tested and analyzed with the design team before ever taking the system online in the field. Both steady-state and transient conditions can be simulated to analyze intelligent load shedding system responses. This technology is currently used with many other third-party ILS systems to validate the logic that has been written for those systems. Whereas with ETAP-ILS, you could use the same tool to validate and configure and operate in real time. Again, this slide here shows the load shedding validation process. You would simulate disturbances, you would analyze the results, you validate the responses, and you implement the recommendations. What makes this a very comprehensive tool is the results are displayed on the diagram and in tabular form. We then transfer these results to the transient stability simulator, and we can then update the controller. As we get feedbacks between the disturbance simulation and the analyzed results, we can readjust and make adjustments to both the simulation and the responses. The ILS priorities can also be adjusted as we go to validate the response. We can also see what the effects are on the total electrical system. So in summary, we can confirm the load shedding actions, simulate the ILS recommendations, and then integrate a very comprehensive stability knowledge base to make sure that the load shedding recommendations will not cause undesirable results once the system goes online. To summarize the key features of ETAP-ILS, it has complete user-defined load priority tables. You have user-defined load groups. You have unlimited load shedding schedules, a very friendly operator interface, the ability to online test and validate your ILS actions. You can also have user-defined trigger inhibits if certain operational parameters require that you take certain priority groups or priority loads out of the system. And it provides the operator with alerts and reactions of the loads about to be tripped. What we'll do now is actually bring up the software and show you ETAP real-time, populating the model with real-time information from the design model that we created in the SPEL example, and then go right into ILS and show you some of the triggers and the visibility that the operators can see in a load shedding scenario.
Bringing the ETAP model online is as simple as clicking the online icon, go online. The ETAP real-time server will go out and connect to metered information coming from the field through communication protocols. As you can see, the information on the ETAP model in green is coming from meters in the field. The information in red is calculated information
that ETAP is calculating based on the real-time information. As I mentioned earlier, there are several different applications that can be used with ETAP real-time. We have advanced monitoring, system playback, automatic generation control, and intelligent load shedding, which we're going to be talking about today. Once the system is online, you will notice there's different color changes, which are user-defined by the designer. The values shown in the cyan color blue here are actual real-time values that are coming in from the field and populating them from the meter devices. The red values are calculated values when you run the state estimation and load flow calculations. As you can see, you can then compare real-time information with calculated values on the ETAP model. Since in many instances in a real operational facility, it is too expensive to put meters on every branch circuit to calculate the loading and the information that the operators may want to see. With ETAP's state estimation engine, and these are the areas in red where we do not have metered information, ETAP can solve the electrical model because it knows all the characteristics and estimate the power flows to each of the individual loads where there's not a metered value. In the areas where there are metered values, you can then do a relative comparison between the actual metered values and the calculated values from ETAP to basically validate the model to make sure the information that makes up the electrical model is accurate and complete. Once the ILS server has been started, we can then move over to the icon and select the ILS trigger monitor mode. This brings up the ILS trigger monitor server screen, which allows us to look at the operation of ILS. What you see on the right-hand side are the multiple circuit breaker loads that could be tripped if we were to lose the primary grid power. On the left-hand side, you can see the different ILS triggers that we use in the systems. They could be things as breaker operations, generator trips, going into an islanding mode, demand exceeded. These are all user configurable by the designer, which allows them to be validated through transient stability studies. What we have in simulation right now is showing the total megawatts of load that is basically be required to shed to maintain the stability of the system if we lose the power grid during operation of the system. As you will see over here on the right-hand side, these are the loads that will be shed, and this is the trigger that we are going to be monitoring if the event happens. When this event happens right now, the loads that are shown in the orange will be the ones that will be shed to maintain the integrity of the system. The representation you're showing on the screen, you'll notice that the circuit breakers are highlighted in orange that are available for tripping. As you see the simulation moving on, they will change from group 1 and shows group 1s, 2, and 3. This is simulating changes in the electrical system based on different conditions that are going on. You also notice down here in the lower right-hand corner the required load shedding megawatts that the system is constantly calculating. In the operational system, ETAP server calculates these values and then sends down to the ILS controller the trigger signals that the ILS controller can react to should an event like a power grid loss happen. The system is preloaded down in the field. What makes this very fast is that the system already has its commands in the local load shedding controllers to trip the loads. It does not have to go back and forth between the real-time server and the controller to activate the trip signals. So in essence, all our controllers that are in the field for high-speed load shedding are preloaded with their set points to trip the loads, and that's how it can be done in less than 20 milliseconds. One of the unique benefits of ETAP ILS is the ability to simulate all the triggers prior to putting the system online. This can be done because ETAP real-time is integrated with our transient stability module inside ETAP design modules. Creating a ETAP transient stability simulation is as simple as clicking on the TS study button within ETAP. From here, the trigger times, the loads to sheds, and the response time from controllers are all transferred to the study case. As you can see, the events that will simulate the ILS triggers are all loaded and now can be actuated in a test environment. This concludes our short demonstration on ETAP ILS and its integrated approach into intelligent load shedding.
ETAP may now initiate the process of generating project files to be sent back to SPEL for them to read. make sure the project file is in edit mode. By clicking the File menu under SmartPlant Electrical, the interface options can be shown. As seen here, we have the option of exporting the ETAP project data and exporting the ETAP cable library. Click on the option to export the ETAP project data. This will allow us to synchronize the project data between SPEL and ETAP. After selecting the option to export the ETAP project, ETAP will ask for the location of the exported project file in XML format to be saved. We can then proceed to export the ETAP cable library data to SPEL. In order to export any ETAP cable library item to SPEL, we will need to verify that the cables in ETAP are already associated with the ETAP cable library. Once we verify this, we can easily export the ETAP cable library. Click the File menu and under SmartPlant Electrical, select the option Export ETAP Cable Library. This will store the ETAP cable library data for the project in an MDV format. The generated MDV file will be used to import the cable library data to SPEL. SPEL's Option Manager has the option to import the ETAP cable library file to SPEL by using the Import Reference Cables option. SPEL can then be used to retrieve the exported ETAP XML project file and complete the synchronization between the two tools.
Okay, so I want to thank everyone on the ETAP side. I'm going to pass it over to Yuval.
All right, very good. Thanks, Ali and team there. It was very good and interesting. Like I said, it is making the whole life cycle support possible here from design all the way to operation. Okay, Yuval, we're already running a little late, so hopefully we can complete your part quickly. Somebody has to pass it on to Yuval, I guess the presenter writes. There you go. Yuval, are you there?
You've muted yourself again, Yuval. There you go.
Cables and browse to the MDB that exported by ETAP for the cable library change. Select the update cable specification and select Power NEC. Select OK to complete the import, review the result, and select Close. The last part would be to import the ETAP project data change. The changes sent by ETAP are the transformer T3 from 300 kVA to 1200 kVA, update the size of the fuse 1 CV3, and size change to cable 1 from 40 AWG to 250 kCV. To retrieve the change in SmartPlant Electrical, click the Tools menu, select ETAP Interface, Retrieve, browse the XML file exported by ETAP, select the file and click Open to start the retrieve process. After finished to retrieve the project data from ETAP, we can open the to-do list and view the tasks. Before we open to-do list, let's review the items and properties we're going to update. Fuse 1 and CV3 going to get the size based on ETAP data. T3 rated power going to change from 300 kVA to 1200 kVA based on ETAP load flow study. And cable 1 going to change from 40 AWG to 250 kcmil based on ETAP sizing. To open the to-do list in SmartPlant electrical menu bar, click SmartPlant to-do list. View the 4 tasks to update cable 1, T3, fuse 1, and CV3. To review the properties change for each task, select the task and click Properties. After review the task, we can run the task one by one or in the batch. To run the 4 tasks in the batch, select all of them and click Run. Close the to-do list. After finish to run the task, let's check the item and verify the value change as a result of ETAP exported study data. Fuse size, circuit breaker size, transformer rated power change, cable size change. If we open the electrical analysis SOD, we're going to see the drawing with the most updated data as well. From electrical analysis SODs folder, select ETAP-SPEL, right-click, and from the shortcut menu, select Open. Review the open drawing by zooming and observe the transformer rated change and the cable size change. At this point, we can continue the design in SPEL. If later in the project, SPEL and ETAP user needs to share more data, we can continue the export-import bidirectional data exchange for project and cable library data and enhance data consistency, improve accuracy, and increase productivity. Okay, thank you. We'll go to
All right,
the
thanks. Yeah, just hand it over to me then. All right, that's very good, and I think that it shows that we have the control, between the two applications, meaning that through the to-do list you always have the end saying of yes, I will take this this change or not. So I mean, it's not automatically without you knowing changes the design. Very good. Thanks, thanks Ali and Yuval. It was very good. Justin, do we have any questions? Or I know we're running late, but maybe we can do one or so.
Yes, Frank, we do have a couple questions. First, does ILS have controllers to execute commands?
Well, that's one for Ali then, I guess.
Yeah, the ILS controllers, they can be either PLC-based controllers, they can be SCL-type relay controllers, any type of device that can have an output to trip a shunt trip a breaker or to drop out a load to work with.
Okay. Well, one more, and I guess the rest we have to answer then through the email system.
Okay, next one. Does the library include different types of starters? For example, VFD, soft starters, etc.
I guess the library in ETAP, I guess they're talking about here. So, Ali, I guess, or the ETAP team, is that one for you?
Can you repeat the question, please?
Sure. Does the library include different types of starters? For example, VFD, soft starters, etc.
For the library actually has different components like cables and, for example, protected devices and all that. There are library items or basically the models of the VFD for harmonics analysis. So basically, you can select the library items for harmonic analysis for VFD. And we don't have library items.
Okay, cool. I think we're running a little late, so I think the rest of the questions we will answer to the response with the information where to download the recording of this. So to wrap it up quickly, then this is the website for the Intergraph customers, which we call the e-customer, where you can actually download these swim lane workflow diagrams and use them as an example. It may be not totally be your work process or workflow, but it may give you some ideas what is possible, and maybe to even improve on your side, if that's an option. So I strongly encourage you, if you have not looked at them, to look at those workflows, the swim lanes. There are also Word documents associated with it with respect to implementation and things to look out for. So very, very interesting and useful information. The other thing is the LinkedIn group. We have the SmartPlant Electrical LinkedIn group. If you're not a member, I encourage you to become a member. It is an interesting and very active group that does all kinds of conversation and exchange ideas and questions, and can be very, very helpful. As we mentioned in the beginning, we have recorded this session, and this session will be placed on our website, and you can then download it for reviewing or passing it on, or review it with your colleagues later on. Also, we have our upcoming conference like we do every year, and this year again, same place, same month, in June the 2nd to the 5th in the MGM in Las Vegas. Nice and warm, and we have a call for papers. So if you are interested in presenting a paper there, you can go to our website and submit a paper. We will waive your registration fee, so it'll be very good, and you have the opportunity to attend the other sessions, workshops, and networking. Lastly, as a little reward for your time, and that we are running a little bit late, is we can give you $100 off if you use this code when you register for the event. So there's a little bit of a reward of attending these webinars. And of course, if you want to really look at the code and everything, you can always look at the recorded session that we'll send in later. Okay, we're run about 10-12 minutes late. Sorry about that, but I think it was a very interesting session showing this whole work process, this whole workflow. And I want to thank Ali and the ETAP team for doing the presentation, as well as Yuval, who got up very early and is right now in Israel, and Justin for hosting it, and of course, last but not least, yourself for attending this webinar, and hopefully we'll find you attending future webinars that we will definitely be conducting during the remainder of the year. So with that, thank you very much.